Hi, in this video I'm going to show you the sensor visualization software I wrote for displaying the real-time data from an IMU, which works on Linux, Mac and Windows. The software is based on Qt and uses OpenGL coprofile as a graphics API. To get the real-time inertial data, I use the B&O USB stick. This is a small PCB which holds a 9-axis IMU which runs a sensor fusion algorithm, an Atmel microcontroller for USB communication and temperature compensated crystal oscillator, and on the other side we have a voltage regulator. The software can be used to visualize either raw or processed sensor data. By clicking the start button, I initiate the broadcast from the sensor, and we now see the live data on the screen: raw magnetometer, gyro, accelerometer and temperature. As you see, whenever I tap on the sensor, gyro and accelerometer exhibit disturbances, while magnetometer data stays virtually constant. Yet when I start to rotate the board and change its orientation, the data of all the sensors show significant change. The measurements from different sensors are fused inside the B&O, and the orientation quaternion is provided as a fusion output. In addition to the raw and processed sensor data, I also implemented the 3D visualization in OpenGL. The window on the left side shows the live quaternion output. The values of the I, J and K components of the quaternion are shown here, and the coordinates of the camera in the 3D space are displayed. The window on the right shows accelerometer data in 3D. The acceleration measurement vector has a blue color, and its corresponding X, Y, Z components colored the same as coordinate axes, namely magenta, yellow and cyan. To navigate inside the 3D scene, I implemented the keyboard shortcut similar to the one from Blender. When pressing 1, 3, 5 or 7 on the keyboard, the camera is moved to a fixed position, where 5 is the default view. It is also possible to navigate freely in the 3D space. I tried to create a similar experience as in Blender, which means by pressing the mouse wheel I can change the camera position, and by rotating the mouse wheel I can zoom in and out. Using the checkboxes for the XY grid, YZ grid and XZ grid, it is possible to switch on and off the grid lines for the corresponding planes, which can be helpful during data evaluation. I am now back at the default view. I have just pressed the number 5, and as we see, each facet of the keyboard has a name. The top, left, front, bottom, right and back are not shown, and each facet has a small widget which shows how the local B&O coordinates are located. Although in this video I spoke only about B&O, it is of course possible to visualize inertial data from other sensors. So here we have it, the visualization software for inertial measurement data with the 3D widgets. I hope you find this useful. Thank you for watching.